Send your use the chromatography to separate everything. Once the parts are separated, you send it through the mass spectrometer. It will measure the mass of whatever is coming through and the mass of the pieces. Now, once it knows the mass and the mass of the pieces, it can match it up with tables of these things and identify what it is that's coming through. It's a little more complicated than IR, the infrared one, but the thing is, it's extremely sensitive and more sensitive than the infrared detectors. In fact, someone I knew who worked with it, he said we had a problem, sort of. Whenever we sent things through the mass spectrometer, they were using a very sensitive one. They always got a signal from plastic, not because they put plastic in there, but because there's plastic everywhere. I mean, they were using plastic, bottles, and they evaporate. Tiny molecules. That's for example. I mean, that's why people can smell things. Let's say you have food you can smell. That's because the food particles evaporate. Now, a dog can certainly sense it better than a person. A bear better than a dog. But even they, I don't think, can sense evaporated plastic. Plastic doesn't smell like anything to them. But tiny amounts of it do evaporate into the air, and their gas chromatography, their mass spectrometer always detected this plastic. It was like interfering with the signals that they wanted to see. So they always had to figure out how to remove this, plastic signal. You see how sensitive the thing is. Even the molecules of plastic that evaporate, manage to be detected by it. So because of all this, the mass spectrometer, they are most often coupled with the gas chromatographer, the gas chromatography. They're coupled with it. So they have devices. That's what, they're rather expensive, but they're very good. They're called GCMSs, gas chromatography mass spectrometry, or mass spectroscopy. The two of that, they send things through the gas chromatography column. Everything gets separated. As they get separated and detected, they also are sent through the mass spectrometer. So that not only do you know what it is, you have a mass spectrum of it, which is more or less, unique. It's certainly easy to identify the obvious compounds from the mass spectrum that you get. So not only is it separated, so you don't have to worry about contaminants, but pretty much exactly what is coming through. So you can identify not only what is there. So this is a very good way of getting a sample from a crime scene, and send it right through the GCMS. Everything gets separated, and you know exactly what it separates into based on the mass spectrum that you get. And you match the mass, if you have to, you match the mass spectrum to a spectrum of things that you know. And yes, we already have mass spectrum of all these kinds of gases, all these kinds of poisons and drugs and alcohol and whatever we need to, whatever criminal compound that we need to match it to, we already have them. So just match your mass spectrum to that. It's more complicated than this because we also have computers that do this automatically. So, but in any event, you get the idea of how it works. You take your sample, you put it through the GCMS, everything is separated, so you don't have to worry about interference. The mass spectrum that comes out will tell us what it is. So, like magic, right? You don't know what the thing is. Send it through the GCMS, and you'll pretty much get your answer of what it is. That's mass spectroscopy. So, you can send it through again, as it goes through, you can put it through the IR, check out the fingerprint region, know what it is. But what's more commonly, we send it through, as it goes through the chromatography column, we send it through the mass spectrometer. So we'll also get the mass spectrum from it, and that will tell us what we get. So the mass spectrum, it doesn't, again, it's enough for us, again, if you are working in the pure chemical field, and you want to know exactly what the compound is, you can't really prove that the mass spectrum is unique. So for that, use the IR, which we know is unique. But as things are going, as we are getting more advanced with mass spectrometers, we have different ways of breaking apart the molecules and different ways of showing that how the different pieces come through. It's getting to be pretty much, the signal from a mass spectrometer is pretty much unique these days, and it's getting better as the techniques increase in sensitivity and in precision. Oh yeah, one more thing about the mass spectrometer: tiny amounts can be found, as we mentioned earlier. So the sample that you want to put in there could be really tiny. So you really don't have to worry about losing. Let's say you only have 1 gram of stuff that you got from the crime scene. That is more than enough to do like several experiments. So even tiny amounts, if you only get them at the crime scene, you don't have to worry. The GCMS will handle it well. So the general idea of how it works: you take you have a suspected material, a solution, maybe a powder, dissolve it, or if it's a lighter solution, you already have it, put it in the GCMS. Now the thing is, it's got to be evaporated in order for the gas chromatography, because it's got to be volatile. If it's not volatile, you can't use a GCMS, but you can couple it with sometimes anyway, you can couple it with, instead of a gas chromatography column, you can go with a liquid chromatography column. We're not going to be, generally you use a gas chromatography, it's good enough. But especially if it's volatile. So again, you take it, dissolve it, put it in GCMS, heat it up, it's now a gas, goes through chromatography, everything gets separated, the M is separated with the chromatography part. And as it goes through, it's identified with a mass spectrometer part. And this can all be done in about an hour, because gases go pretty quickly. And again, it's an expensive device, but it does a great job, very effective at separating all the components and identifying all the components in an incontrovertible way, pretty much. So it's a great way to prove you know exactly what was in that sample. It was mentioned before that we have presumptory tests for chemicals, and to have the confirmatory test, they often throw it through a GCMS or a mass spectrometer, because once you put it through the mass spectrometer and you have the original presumptive test, you're pretty much guaranteed you know exactly what it is. So, and all is done in about an hour. So it's a very convenient way of finding out what your stuff is. So a little bit of a review. You should know about chromatography, how it works. Things go through a column. Different components stick differently, and therefore come out at different times. Different times of chromatography, gas chromatography, the liquid, different types of detectors. Basically, absorption, fluorescence, infrared, and mass spectrum detectors. Okay, so you know how they're different, what they are, and what they can show, and how we combine chromatography for separation and spectroscopy for identifying what it is. Chromatography separates everything into nice little components, different, so you don't have any interference, and spectroscopy identifies what it is after you separate it, so you don't have to worry about interference. Here are some homework problems. If you want some practice with the information that we went over here.